Hello, student. In last lecture, we have discussed about the dispersion and what is the reason behind this dispersion. Basically, the dispersion is because of the group delay in the group velocity, and this can be measured as a d. D here, d is the this parameter gives the value of dispersion. So here, this is dispersion. This is the length of fiber. This is spectral bandwidth, and this is the group velocity. So this is the formula to calculate the dispersion. This is also known as a GVD because this is dependent on the group velocity, or the reason behind this dispersion is delay in the group velocity of optical signals. So now this dispersion, or we can say intramodal dispersion, occur in the multimode fibers, and again this is of two types. So the dispersion, intramodal dispersion is of two types, material dispersion and the waveguide dispersion. These are the two types of intramodal dispersion. Now next, what is the material dispersion? So this is the optical fiber. Here you can see this is the optical fiber, and this is the emitter. Emitter is emitting input signals, and this is the output. This is cladding core. From here, the signal travel through this optical fiber having velocity Vg, and this velocity is dependent on the wavelength. So waves in the guide with different free space wavelengths travel at the different group velocity. Here the velocity difference in the velocity is because of the wavelength dependency, and wavelength dependency on the actually this core and cladding have different refractive index. In first unit we have discussed about this core and cladding, and what is the significance of refractive index while the propagation of optical signal or on the modes of optical signal propagation. So this wavelength is dependent on the refractive index. Again, the group velocity is a function of wavelength, so it also differ and results in the broadening of output pulse. Here you can see this is the spectral bandwidth, this is the input signal, and there is a spread in this input signal. When we measure the intensity of output optical signal at the output, then we give wave we obtain waveform like this. So this is because of this material dispersion. So material dispersion occur because the index of refraction vary with the refractive index. So basically this is caused by the change in the refractive index. So how you will calculate the material dispersion? So for material dispersion, first we calculate the group delay. So here few assumption is to be made. The first assumption is we assume that there is a plane wave propagation in an homogeneous medium with refractive index of n. So first this is the assumption, and then the refractive index of the material varies with the wavelength and given by n lambda. We have written refractive index as n bracket. In bracket there is a wavelength. It means it is indicating that the refractive index is dependent on this wavelength and varies as a function of this wavelength. So now we have to calculate the group delay. So how you will calculate group delay? In previous video we have discussed the formula about the group delay calculation. So here we are dealing with material dispersion. So group delay, this is representing the group delay of the material dispersion. This is given by L d beta by d omega. Beta is the propagation constant and omega is the frequency. So we extract the constant and at last we will get this formula. So on rearranging this, we will get this equation. Now next, the pulse spread due to material dispersion. What will be the pulse spread? So pulse spread is given by, so for this, what we have to do? We have to calculate the parameter, dispersion parameter, that is indicated by d mat at lambda. So for this, how we calculate this? Group velocity is given by this formula. In last lecture we have discussed this. Now on solving this, we will get this formula, and in this d mat gives the material dispersion which is dependent on the wavelength. So this is all about the material dispersion. So basically you have to remember that the material dispersion is because of the dependency of refractive index on the wavelength. So this is the formula to calculate the refractive, calculate the material index. Here few case studies are given. So this graph is showing the re refractive indexes is the function of wavelength. So here you can see as the wavelength increases, as the refractive index increases, the wavelength is also increases. So this is basically, this case study is done using the silk optical wavelength of silica material. So here the fiber is made up of silica, and in this case we have used silk oxide and some other compositions, and for this material dispersion is calculated as a function of wavelength. So this is taken from the book Optical Fiber Communication, third edition, Keyser, Tata McGrahy publication. You can refer this in more detail in the given book. In next class, we will discuss about the waveguide dispersion. And there will be two reasons for the intramodal dispersion. One is material dispersion and another one is waveguide dispersion. So we will see waveguide dispersion in next class. Thank you.